All right, welcome. Today we're diving into some of the invisible magic that, honestly, keeps the internet from completely falling apart when things get really, really busy. We're going to break down exactly how the services you use every single day, streaming, shopping, all of it, manage these huge waves of digital traffic without just crashing.
I mean, have you ever really stopped to think about it? The finale of some massive show drops and literally millions of people, you, me, everybody, log on at the exact same second, and it just works. So how is that even possible? Well, it's not magic, but it is some incredibly smart engineering, all designed to handle what is basically a digital stampede.
Okay, so to really get our heads around this, let's use an analogy that I think we can all relate to. Just picture a huge supermarket, right? It's the day before a big holiday. Now imagine they only have one checkout lane open. Just one. Can you picture the chaos? It would be an absolute disaster. We're talking long lines snaking down the aisles, frustrated customers, just total madness.
And that right there, that's the core problem we're talking about. It's a digital traffic jam. See, in the online world, that one single cashier, well, that's a single server. And just like that poor, overworked cashier, one server can only handle so many requests at once before it gets completely and totally overwhelmed. So when that one server gets hammered with thousands or even millions of requests, people trying to stream, shop, log in, all at the same time, it grinds to a halt. The whole system fails. And for you, the user, what does that look like? Well, you get that dreaded loading spinner that never goes away, maybe a timeout message or that classic service unavailable error. It is just a terrible experience for absolutely everyone involved. So what's the solution, right? How do you fix this mess? Well, you obviously don't just rely on that one cashier. You open up more checkout lanes. And this is the important part, you bring in a smart, super efficient manager whose whole job is to direct the flow of customers. In our digital world, this smart manager has a name. It's called a load balancer.
So this load balancer, it's basically a digital traffic cop. Or, sticking with our analogy, it's that savvy supermarket manager. Its one and only job is to stand at the front door and intelligently direct every single incoming request to a whole team of servers that are waiting in the back. Now, it doesn't process the request itself. It doesn't do the checkout. Its job is just to make sure no single server gets absolutely buried in work.
Okay, but how does it decide where to send each request? I mean, this can't be random, right? And it's not. Our smart manager has a whole playbook filled with different clever strategies to make sure the workload is balanced out just right. So let's actually take a look at some of the most common techniques in that playbook.
All right, first up, we've got the most straightforward technique. It's called round robin. You can think of this as the manager's simplest, most predictable move.
So back in our supermarket, a manager using round robin would just point. Okay, you go to cashier 1. Next person, you go to cashier 2. Next, cashier 3. And once they hit the last cashier, they just loop right back around to the beginning. Simple, right? It definitely distributes the work, but it doesn't really care if cashier 1 has someone with just one item while cashier 2 is stuck dealing with a super complicated return that's taking forever. So it's fair, but it's not always the most efficient way to do things.
And that weakness brings us to a much smarter strategy, the least connections method. Now, this is what a real experienced supermarket manager would actually do. It's all about paying attention.
The contrast here is really the key. Round robin just blindly assigns requests in a circle, but least connections, it's way smarter. The manager actually looks at all the checkout lines first, sees which cashier has the shortest line, and then sends the next person there. This is a huge improvement because it's actively adapting to the real-time workload of each and every server.
But what if your cashiers aren't all created equal? What if you've got a seasoned pro who can scan items twice as fast as the new trainee you just started? Well, in the digital world, this happens all the time. Servers often have very different amounts of power, and that's exactly where weighted methods come into play.
Here's how this works. It's actually pretty clever. We just assign a weight to each server based on how powerful it is. So server A, that's our pro cashier, it gets a higher weight, let's say a 3. Server B is our new trainee, so it gets a weight of just 1. Now the load balancer knows, okay, for every 1 request I send to the trainee, I'm going to send 3 to the pro. This makes sure our most powerful resources are always doing the heaviest lifting.
All right, finally, there's one more special situation we need to cover. Sometimes it's absolutely critical that a user sticks with the same exact server for their whole visit. Think about things like an online shopping cart or when you're logged into a website. For that, we use a technique called IP hash.
Just think about it for a second. Let's say your cashier needs to pause your transaction to do a price check. You have to go back to that specific cashier to finish paying, right? You can't just wander over to a different lane and expect them to know what was in your card. That's what IP hash does. It makes sure a user is always sent back to the same server, creating something we call session persistence, or a term I like, stickiness.
Okay, so let's just pull all of this together really quick. You've got round robin, which is great for simple setups where all your servers are basically the same. Then there's least connections, for smarter, active balancing when the workload is all over the place. Weighted methods are perfect for when your servers have different power levels. And finally, IP hash is absolutely essential for things like shopping carts or logins, anything that needs to remember a user from one click to the next. So, what's the big takeaway from all this? Well, the most important thing to understand is that there's no single best strategy. It's all about picking the right tool from the playbook for your specific situation.
And you can pretty much figure out which one to use by asking yourself 3 simple questions. First, are all my servers equal, or do some have more horsepower? That'll tell you if you need to think about a weighted approach. Second, do my users need to stay on one server, like for a shopping cart? If the answer is yes, then you're looking at IP hash. And finally, number 3, what's my main goal here? Am I going for pure simplicity, like round robin, or do I need the best possible performance, like with least connections?
Because ultimately, it all boils down to this one idea. The goal isn't just to distribute traffic, it's to distribute it intelligently. Modern web services are all about managing that flow with foresight to create a seamless, fast, and reliable experience for every single one of us.
And that kind of leaves us with a final thought to chew on. As our digital world keeps growing, these traffic jams are only going to get bigger and more frequent. So here's a question for you. If you knew your traffic was going to double next year, which one of these strategies would you choose? How would you set up your smart manager to handle that rush? Something to think about. Thanks for joining me.